Welcome to the studio, developers. Today, let's learn about small language models. For the longest time, the entire narrative around artificial intelligence has been absolutely dominated by massive scale. We've basically been told that to get better performance, we simply need more data, massive amounts of compute, and bigger parameter counts. But what if that isn't the whole story? What if the future of practical AI isn't just about building the absolute biggest brain, but actually building the most efficient one?
It really makes you wonder, right? Do you actually need the biggest model for every single task you tackle? For years, the AI world was basically just chasing sheer scale, assuming bigger was automatically better. But now, the smartest labs and the most practical developers are starting to go in the exact opposite direction. They're realizing that brute force isn't always the most elegant or even the most affordable solution.
Okay, here's our game plan for today. We'll meet the language models, compare the strengths of the large ones versus the small ones, figure out how to choose the right tool for the job, and finally, dive into the massive industry shift hitting us in 2026.
Because this is exactly what we're seeing right now. The AI industry is rapidly moving away from the pure conceptual hype of massive scale and getting real. Localized, super-efficient small language models, or SLMs, are rising up as a completely viable, serious alternative to those massive cloud-based systems.
So, let's jump right into part one. Meet the language models. Let's lay out the playing field here. When we look at the two main contenders side by side, the difference in scale is literally mind-boggling. On one hand, you've got large language models, or LLMs. These are huge, packing anywhere from 100 billion to well over 1 trillion parameters. Because they're that gigantic, they come with a really high cost and absolutely require heavy cloud infrastructure to run. On the other hand, we have small language models, SLMs. These guys are super lean, usually sitting right in that 1 to 13 billion parameter sweet spot. And the best part, they cost practically nothing to run, and you can spin them up locally, right there on your laptop.
Moving on to part two, strengths of large models.
So let's talk about the heavyweights first. It's really important to understand what LLMs actually do best, so we know exactly when their massive scale is justified. You're probably already super familiar with the big names here: GPT-4o, Claude Opus, Gemini Ultra. These represent the absolute cutting edge of raw, generalized AI capability.
And they are powerhouses for a reason. These massive models absolutely shine when you need deep, nuanced, complex reasoning. They are unparalleled at creative, open-ended tasks, deep research, and drawing on a massive base of general knowledge. Need to connect abstract dots across multiple domains? You go to an LLM. But, and this is a big but, the trade-off for all that incredible power is the high cost and the fact that you are entirely dependent on cloud connectivity.
Which brings us to part three, strengths of small models.
Now, this is where things are getting genuinely exciting. We're seeing this totally disruptive rise of lightweight alternatives. I'm talking about models like Phi-4, Mistral, Gemma 3, and QN3. Sure, they only have 1 to 13 billion parameters, a fraction of the size of the giants, but they are punching so far above their weight class. Because they're so highly optimized, they're quickly becoming the go-to tools for local AI execution.
Why are developers flocking to them? Well, because SLMs are perfect for highly specific, narrowly defined tasks. You want to use these when speed, cost, and most importantly, data privacy matter way more than having a general know-it-all AI. They run perfectly on edge devices, meaning your sensitive data never ever has to leave your local machine to go to some third-party cloud. You get blazing fast responses, super low cost, and total control.
All right, part four, choosing the right tool.
Let's put this into practice with a quick mental framework. Imagine you're tasked with drafting an incredibly complex legal document. Or maybe you need an AI to help you write code across a massive, intricate code base. You need broad knowledge and nuanced reasoning for that, right? That is 100% an LLM moment. But let's flip the scenario. Say you're building a tool to summarize customer support tickets, and those tickets are packed with sensitive user data. You need to do this quickly, cheaply, and entirely on-device to maintain strict privacy. In that case, raw general capability takes a backseat. That is absolutely an SLM moment.
Here's the easiest way to remember it, and it's a great analogy. LLMs are your Swiss Army knife, but SLMs are your scalpel. The large model is your multi-purpose, do-it-all tool. You bring it when you don't know exactly what you're going to face. But the small model, that's your precision instrument. It does one specific thing in a very controlled environment flawlessly.
Let's wrap this up with part 5, the 2026 industry shift.
This whole dynamic we've been talking about is actually causing a massive realignment in tech, and it's accelerating as we look toward 2026. IBM actually calls this the battle of frontier versus efficient. The frontier models push the theoretical boundaries of what AI can conceptually do, but the efficient models are doing the actual, everyday heavy lifting. The industry is waking up to a harsh physical and economic reality. We literally just cannot keep scaling massive cloud compute forever. The energy, the chips, the cost, there is a ceiling.
And that is exactly our reality right now. Because compute can't scale infinitely, running highly capable AI locally on edge hardware is officially moving out of the hype cycle and into practical reality this year. The adoption of edge hardware is accelerating so fast, giving everyday developers and organizations totally new, powerful local options that simply didn't exist a short time ago.
So what's the big takeaway for you? Well, the future isn't about small models entirely replacing big models or vice versa. We are definitely going to need both. The new AI literacy isn't just knowing how to prompt, it's knowing exactly when to reach for that scalpel and when to grab the Swiss Army knife. It's about architecting smart solutions that use the right tool for the exact right job.
So as you sit down to architect your next application, I want to leave you with this question. Will you reach for the Swiss Army knife, or will you reach for the precision of the scalpel? Think carefully about your specific requirements for privacy, speed, and cost. If you enjoyed the video and learned something new today, make sure to hit the like and subscribe button along with the bell icon.